America spent decades building the most advanced semiconductor ecosystem in human history. Then it spent the next 3 decades teaching other countries how to replicate it. That sounds absurd, yet here we are. The country that invented the microprocessor, pioneered modern chip design, built Silicon Valley, and created companies like Intel, AMD, Nvidia, and Qualcomm is now spending hundreds of billions of dollars trying to bring manufacturing capacity back home. Not because America forgot how to make chips, because making them somewhere else became too profitable. And that distinction matters. When people talk about the semiconductor race today, the conversation usually begins with China's rise. New fabs, massive subsidies, Huawei's comeback, SMIC's progress despite sanctions. I think that's the wrong starting point. The more interesting question is how China acquired the foundation necessary to attempt any of this in the first place. Because semiconductor industries don't appear overnight. You don't wake up one morning and decide to build advanced chips. You need engineers, supply chains, materials expertise, equipment maintenance teams, packaging specialists, university programs, industrial culture, tens of thousands of people who know exactly what to do when something goes wrong at 3 in the morning inside a fabrication plant. That ecosystem took America generations to build, and then, piece by piece, portions of it moved overseas. The stakes are much larger than smartphones or laptops. Semiconductors sit inside fighter jets, missile systems, satellites, power grids, medical equipment, financial networks, and increasingly, artificial intelligence systems. Whoever controls the production of advanced chips doesn't just control a lucrative industry. They influence the technological ceiling of entire economies. That's why the semiconductor sector has become the center of strategic competition between the United States and China. But here's the part that rarely gets enough attention. Many of the mechanisms China used to accelerate its chip industry were not created in Beijing. They were created in boardrooms. During the 1,990 seconds and early 2000 seconds, American companies were rewarded for reducing costs and increasing shareholder returns. Manufacturing moved where labor was cheaper. Supply chains stretched across oceans. Production became globalized. Wall Street loved it. Consumers loved it. Politicians from both parties mostly supported it. For a long time, the arrangement seemed brilliant. Products became cheaper, corporate profits expanded, quarterly earnings reports looked fantastic. Everyone appeared to be winning. Except something important was happening beneath the surface. Manufacturing knowledge wasn't staying still. Every factory built overseas trained workers. Every supplier developed expertise. Every partnership created relationships. Every production line transferred practical knowledge that rarely appears in patents. A patent can tell you what to build. Experience teaches you how to build it consistently. Those are very different things. Meanwhile, China wasn't approaching semiconductors as just another business sector. Beijing increasingly viewed advanced chips as a national security priority. Programs tied to the Ministry of Industry and Information Technology, state-backed investment funds, and long-term industrial plans poured resources into capabilities that Western firms often considered too expensive or too slow to develop. One side was optimizing for quarterly results. The other was preparing for decades. And for years, the gap between those approaches wasn't obvious. After all, American firms still dominated the highest value segments of the industry. Nvidia designed leading AI chips. Qualcomm dominated mobile processors. Applied Materials and Lam Research supplied critical equipment. The ecosystem still looked overwhelmingly American, which is why almost nobody noticed the warning signs. The manufacturing footprint was shrinking. The talent pipeline was dispersing. The industrial muscle memory that once sat comfortably inside the United States was spreading across Asia. And the consequences of that decision wouldn't become visible until much later, when a new technological revolution arrived, and Washington suddenly realized that some of the most important factories in the world were no longer on American soil. The story gets much more uncomfortable when we look at the specific decisions that made that outcome possible. For years, the United States looked at semiconductors and saw a business. China looked at semiconductors and saw a vulnerability. Those two perspectives produced very different decisions. To understand what happened, we need to leave Washington for a moment and step into an industrial park in Taiwan during the late 1980 seconds. This is where one of the most important companies in modern history quietly emerged, TSMC. Today, Taiwan Semiconductor Manufacturing Company produces the overwhelming majority of the world's most advanced chips. Yet the company was founded around an idea many American executives initially viewed with skepticism. Instead of designing chips and manufacturing them, what if a company only manufactured them? At the time, vertically integrated giants like Intel dominated the industry. Design and production lived under the same roof. It was expensive, complicated, and difficult to replicate. TSMC changed the equation. Suddenly, American firms could focus on design while outsourcing fabrication to specialists. Economically, it made perfect sense. Strategically, the long-term consequences were less obvious. Companies such as Nvidia, Qualcomm, Broadcom, and AMD became extraordinarily successful using this model. They could concentrate resources on architecture, software, and innovation, while someone else handled the staggering costs of manufacturing. Wall Street rewarded the shift. Investors saw higher margins. Executives saw lower capital expenditures. Consumers got better products. Everybody had a reason to keep moving in the same direction. The problem was that semiconductor manufacturing isn't just another factory process. A modern fab is one of the most complex environments humans have ever created. Tiny vibrations can ruin production. Temperature fluctuations matter. Microscopic contamination can destroy millions of dollars worth of wafers. The knowledge required to run these facilities isn't learned from PowerPoint presentations. It's accumulated through repetition, year after year, generation after generation. And that expertise began concentrating in Asia. At first, this wasn't viewed as a threat. America still controlled the most profitable segments of the industry. Intel remained dominant, Nvidia was growing, Qualcomm was thriving. The United States still sat at the center of semiconductor innovation. But manufacturing capability was becoming geographically concentrated, very concentrated. By the early 2022s, Taiwan alone accounted for a significant share of global semiconductor production, including the overwhelming majority of leading-edge chips. Think about that for a second. The digital infrastructure of the modern world increasingly depended on factories located on an island roughly 180 kilometers from mainland China. That's not diversification. That's concentration disguised as efficiency. And while Western corporations optimize global supply chains, Beijing was studying them, patiently. Chinese officials understood something many investors ignored. If advanced manufacturing creates expertise, then expertise can eventually create competition. The government launched a series of industrial initiatives designed to close technological gaps. State-backed funds directed billions into semiconductor development. Universities expanded engineering programs. Domestic firms received support that would make most Western free market advocates deeply uncomfortable. Not every project succeeded. Many failed. Some failed spectacularly. China spent enormous sums chasing technologies it couldn't yet master. Critics pointed to those failures as proof that the strategy wasn't working. I think that's where many observers misunderstood the situation. Because the goal wasn't winning immediately, the goal was building capability. There's a difference. An unsuccessful chip project still trains engineers. A failed fabrication facility still creates technical experience. An underperforming supplier still learns. Industrial power is often accumulated through mistakes rather than victories. One dry observation here. The West frequently mocked China's semiconductor failures while simultaneously helping train many of the people who would eventually solve those problems. That's a remarkable level of confidence. Or complacency. Maybe both. Meanwhile, another development was quietly reshaping the industry. American firms increasingly relied on Chinese manufacturing for electronics assembly, packaging, testing, and broader supply chain operations. Each stage added knowledge. Each stage expanded local expertise. Each stage created another layer of industrial competence. None of this looked dangerous in isolation. That's the important part. No single decision triggered alarm. No CEO stood up and announced, "Today, we will help create a future competitor." The process was gradual, rational, profitable, and almost invisible. Remember that distinction between patents and experience from earlier. We're finally approaching the moment where that difference starts to matter. Because by the time Washington recognized semiconductors as a geopolitical weapon, rather than merely a commercial product, China had already spent years accumulating something far more valuable than blueprints. It had accumulated people who knew how to turn those blueprints into reality. And once that knowledge reaches critical mass, the story changes in ways many policymakers didn't expect. By 2022, Washington had reached a conclusion that would have sounded almost unthinkable 20 years earlier. The world's most advanced technology industry had become a national security issue. Not a trade issue, not an investment issue, a national security issue. That's why the Biden administration launched sweeping export controls targeting advanced semiconductor equipment, AI accelerators, and the technologies required to manufacture cutting-edge chips. The logic was straightforward. If China couldn't access the most advanced tools, it couldn't catch up, at least not quickly. And to be fair, there was real logic behind that strategy. The semiconductor supply chain contains critical bottlenecks that remain extraordinarily difficult to replace. Take lithography. The Dutch company ASML produces the world's most advanced EUV lithography machines. These systems contain hundreds of thousands of components, cost more than $200 million each, and require expertise accumulated over decades. Building one isn't like building a factory. It's closer to recreating an ecosystem. The United States, Japan, the Netherlands, Germany, and a handful of other countries still control many of these crucial choke points. Supporters of export controls point to this reality and argue that China remains years behind at the highest end of semiconductor manufacturing. They're not wrong, but this is where the story becomes more complicated. Because the objective wasn't necessarily to surpass America tomorrow. The objective was survival. And survival changes how you think. When access to foreign technology becomes uncertain, self-sufficiency suddenly becomes far more attractive. Every restriction becomes an incentive. Every sanction becomes a deadline. Every block shipment becomes a reason to invest harder. History is full of examples. America's aerospace industry accelerated during geopolitical competition. The Soviet space program emerged under strategic pressure. Japan's post-war industrial rise was fueled partly by necessity. Constraints can slow development. Sometimes they also focus it. Then something happened that forced people to reconsider assumptions. Huawei came back. Not completely, not effortlessly, but it came back. When Huawei released the Mate 60 Pro in 2023, featuring an advanced domestically produced processor manufactured by SMIC, analysts across the world paid attention. The reason wasn't that China had suddenly overtaken the United States. It hadn't. The reason was that many experts believed such progress would take much longer. Instead, a company operating under some of the toughest technology restrictions on Earth found a way to keep moving. That matters. Not because one smartphone changes the balance of power, because it revealed that the gap between impossible and difficult had been misunderstood. There's a huge difference between those two words. Remember the opening question? How does a country build a sophisticated chip industry after another nation spends decades establishing dominance? Most people assume the answer is technology transfer, or industrial espionage, or government subsidies. Those factors exist, but I think they're incomplete explanations. The deeper answer is accumulated capability. Factories, engineers, suppliers, managers, toolmakers, materials specialists, thousands upon thousands of people learning one small piece of a gigantic puzzle over many years. That's much harder to measure than patents. It's also much harder to stop. And here's the reversal that changes the entire story. America did not lose leadership. In many critical areas, it remains firmly ahead. Nvidia dominates AI accelerators. AMD continues pushing high-performance computing. Applied Materials, KLA, Lam Research, Synopsys, Cadence, the list goes on. The United States still occupies commanding heights across semiconductor design, software, equipment, and research. The real issue isn't that America stopped being strong. It's that the rest of the world became stronger too. Those are not the same thing. For decades, American policymakers often evaluated semiconductor leadership through market dominance. Yet industrial competition doesn't work like a winner-take-all video game. A rival doesn't need to surpass you to create problems. They only need to become good enough. Good enough to build alternatives. Good enough to survive sanctions. Good enough to reduce dependence. Good enough to challenge pricing power. Good enough to force strategic choices. That's where China increasingly finds itself. Not at the summit, but much closer to the mountain than many expected. And that creates a difficult question for Washington. Because if sanctions slow China's progress, but simultaneously accelerate China's determination to build an independent ecosystem, what exactly does success look like? I'm not entirely certain policymakers have answered that question themselves. And the next phase of this story may matter more than anything we've discussed so far. Because the future of the chip industry won't be decided by factories alone. It will be decided by artificial intelligence. And AI is changing the value of semiconductors faster than governments can write policy. The next chapter of this story isn't really about chips. It's about intelligence. Artificial intelligence has transformed semiconductors from a profitable industry into strategic infrastructure. The companies that design AI models need increasingly powerful processors. Governments need them. Militaries need them. Financial systems need them. In a very real sense, the race for AI is becoming a race for computing power, and computing power runs on chips. That's why the United States is investing hundreds of billions through initiatives like the CHIPS and Science Act. Washington isn't trying to recreate the semiconductor industry out of nostalgia. It's trying to rebuild capabilities that policymakers suddenly realized were too important to leave entirely offshore. Whether that effort succeeds remains an open question. Building a fab is difficult. Building an ecosystem is harder. You can spend billions constructing facilities. Creating decades of manufacturing culture is another challenge entirely. Meanwhile, China continues moving forward, not at the pace Beijing would like, not without obstacles, certainly not without technological bottlenecks, but forward nonetheless. That's the reality many discussions miss. This isn't a movie where one side wins and the other loses. It's a long competition between two enormous systems adapting to each other's moves. And my view is that both countries have already learned different lessons from the same experience. China learned that dependence is dangerous. America learned that efficiency and resilience are not always the same thing. For 30 years, the global economy rewarded efficiency above almost everything else. Lowest cost, fastest production, highest margins. The semiconductor industry became one of the greatest achievements of that model. It also exposed its weaknesses. Because when a supply chain becomes critical enough, economics eventually collides with geopolitics. And geopolitics usually wins. Remember the contradiction from the beginning. How did America build the world's most advanced chip industry and then help create its most serious challenger? I don't think the answer is incompetence. I don't think it's a secret conspiracy either. The answer is much simpler. Millions of rational decisions made sense individually. Together, they produced an outcome almost nobody intended. History works like that more often than we'd like to admit. My prediction? The next decade won't be defined by whether China overtakes America or whether America contains China. It will be defined by how much duplication both sides are willing to pay for. Because resilience costs money, redundancy costs money, national security costs money. And for the first time in a generation, the world's largest economies seem willing to pay that bill. Which brings us to the irony at the heart of this entire story. After spending 30 years building a globalized semiconductor industry, the world's biggest powers are now spending trillions trying to make it less global. The engineers must find that at least a little amusing. If you enjoyed this deep dive, subscribe and come back for the next one. There are plenty more stories hiding inside the technologies we use every day.